Welcome back, ladies and gentlemen. Today we're going to be discussing mean, standard deviation, and the 5-number summary. Right. In addition to describing what we observe in the graphs of the data, there are key features that we need to calculate to further quantify our observations called summary statistics. The summary statistics we use when describing a distribution change depending on the shape observed in the graph of the data. That's why we discussed shape yesterday. Right, so this is part 2 of how to describe a quantitative distribution. Now the first value that we're going to discuss that you want to calculate is the center. So as you can see in the graphs below, the 3 measures of central tendency will be equal in a perfectly symmetric distribution. Right? You can see that right here in this graph. So mean, median, and mode are going to be exactly in the center where the peak occurs in a perfectly symmetric distribution. Now it's important to note that real-world data very rarely generates a perfectly symmetric distribution, which is why we generally describe such distributions as roughly symmetric. In other words, it's close enough to describe it as symmetric even if it's not perfect. Now in contrast, the mean and median pull away from the peak of the distribution in the direction of skewness. So when you have a roughly symmetric distribution, mean, median, and mode are going to be very close to each other. If it's perfectly symmetric, they're going to be identical to each other. And when you have a skewed distribution, the mean and median will pull away from the peak in the direction of the skewness. Now, the mean is the average of the data. All right, to calculate the mean, you find the sum of all values and then divide by the total number of values in the data set. Right, the mean is most often used to describe the center of symmetric distributions. The mean should not be used when describing a skewed distribution because the extreme values creating the skewness observed in the graph of the distribution will exaggerate the measure of center, and this exaggeration is called bias. Right, so calculating the mean when you're dealing with a skewed left or skewed right distribution, do you see how much more distorted the mean is than the median? The median will still measure the true center point of the data set, but the mean is going to be pulled much further in the direction of any sort of skewness that's occurring. Whereas the median only gets pulled away from the peak, it still represents the perfect 50% mark in the data. Now, when a distribution is skewed, we need to use a measure of center that's resistant, in other words, unaffected by skewness or extremes, when describing its center. Right, the median is a value that perfectly divides the distribution in half. 50% of data is less than the median, and 50% of data is greater than the median. In an odd-numbered data set, the median will be the middlemost number. However, in an even-numbered data set, the median will be the midpoint of the 2 middlemost numbers. Now, since the median is calculated by arranging the data from least to greatest and by counting to the middlemost value, it's resistant to extremes, meaning it's unaffected by them. All right, the median can be used with distributions of any shape. However, it's most often used when describing a distribution that is skewed or contains extreme values. Okay. Now, aside from measures of center, we also have to describe how spread out the data is. All right, so in addition to identifying center of a distribution, it's important to describe how variable the data is. All right, since maximum and or minimum values of a distribution could be an outlier or extreme value that is removed from the overall pattern of the distribution, statisticians need measurements other than the range to describe a distribution's variability. Now remember, range is the difference between the maximum and the minimum. You literally take maximum minus minimum to calculate range. That's a value that you have learned in the past. All right, there are 2 measurements that we use in addition to the range when describing the spread of a distribution: the standard deviation and the interquartile range, also known as IQR. And each measurement corresponds to a specific measure of central tendency. All right. Now, the standard deviation measures the average distance of the data points in a distribution from their mean. So when you look at all of the points in a distribution, how far off are they on average from the mean value? All right. Now, to calculate this, we calculate the mean of the numbers first. Then we find the deviations from the mean, so we calculate the observation minus the mean. We square each deviation, calculate the sum of the squared deviations, which means we're adding up all of our answers from step 3. We divide the sum in step 4 by the number of observations minus 1. Now, observations minus 1 first, then do your division. And then we take the square root of the answer from step 5. Right, so the overall formula looks like the following. All right, standard deviation of our variable is going to equal the square root of the sum, all right, this is capital sigma, this is the summation symbol, of all of our observations minus the mean, quantity squared, divided by the number of observations minus 1. All right, so first we calculate the mean so that we can actually do our subtraction. Then we find the deviations, observation minus mean. We square each of those deviations. We find the sum of all of those squared deviations. So after you've squared all of those, you add them all up. We divide that sum by the quantity found by taking the number of observations we have in the data set, minus 1, and then take the square root of everything. Now the example below shows how to calculate the standard deviation of a distribution without a calculator. Now in this instance, the standard deviation states that the number of pets owned by this group of students varies by 2.55 on average from the mean of 5 pets owned. Now notice that 2.55, that doesn't really make sense based on the variable being the number of pets that students own, but it doesn't have to. This is just the average deviation from the mean. This is the average distance of all of these data points from the mean value. All right, so let's take a look at this one. All right, so if we find, see, our average is 5, so if we look at the deviations over here, we would have to take 7 minus 5, which is 2, 8 minus 5, which is 3, 9 minus 5, which is 4, and we would have to square those. Over here you can see a table where each of the data points is listed out exactly as many times as it appears. And we've taken the observation minus the mean of 5 in each instance. Now when you take those and square them, notice that there are parentheses around the deviation. You have to square the sign of the deviation along with the deviation itself. If you don't use parentheses, then you would get negative answers for those squared values, and you're not allowed to have those. All right, so when you square all of these, we get 16, 4, 1, 1, 1, 0, 4, 9, 16, and so on. Kind of like, this kind of reminds me of distance formula, but in a much more massive manner. All right, so we squared each deviation, find the average squared deviation, so calculate the sum of the squared deviations, and then divide by how many you had minus 1. There are, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So if we had 9 minus 1, we would be dividing by 8 up in this formula. And then when you calculate the square root of that answer, that's when you actually get your standard deviation. All right, so the sum of the squared deviations was 52, divided by 9 minus 1, which is divided by 8, gives you about 6.5. Take the square root of 6.5, you get 2.55. My decimal didn't really show up very well there. And again, this represents the number of pets owned by this group of students varies by 2.55 pets on average from the mean of 5 pets owned. All right, it just tells you how spread out those points are on average from the mean. Now, since the standard deviation describes the average distance from the mean, it is not resistant to extreme values, just like the mean is not. All right, so like the mean, we only use standard deviation to describe the spread of roughly symmetric distributions. Now you might be wondering, why are we so interested in the mean and standard deviation if they have limited use? There are a lot of operations that we use in statistics to calculate whether or not we have what we like to call statistically significant results in our experiments and in our studies. And the easiest way to calculate the probability that governs that is by using a normal distribution with a mean and standard deviation to define it. And there are ways to ensure that the data sets that we use for those calculations are in fact normal. We'll talk about normal distributions at the very end of this unit. All right, now, when we can't use standard deviation, the interquartile range, or IQR, is the measure of spread that we use with skewed distributions and/or distributions with extreme values. All right, the interquartile range, IQR, describes the spread of the middle 50% of the data, and it's defined as interquartile range is equal to the third quartile minus the first. Right, now to calculate the interquartile range, you first have to find the quartiles of the distribution. The first quartile is the median of the first half of the data. So it's the middle of the first half. If you completely ignore the second half, it's going to be right there in the center. The third quartile is the median of the second half of the data, the upper half. Now the second quartile is the median. We haven't forgotten the second quartile. And you might have noticed that each of these percentiles start with the prefix quart, meaning divided into 4 parts. All right, so your data is actually divided into 4 equal parts, meaning divided into 25% segments when you first find the median, and then you find the lower and upper quartiles, so the first and the third quartiles. Remember, that second quartile, 2 out of 4 would be 1/2. That's why that corresponds to the median. Right. Now, the minimum and maximum values alone tell us little about the distribution as a whole. All right, likewise, the median and quartiles tell us little about the tails of a distribution. To get a quick summary of both center and spread, combine all 5 numbers. The 5-number summary of a distribution consists of the smallest observation, the minimum, the first quartile, the median, the third quartile, and the largest observation written in order from smallest to largest. All right, so let's go ahead and calculate the summary statistics for the distribution of heights in my fall 2021 AP Statistics classes. Now, although it's useful to know how to complete these calculations by hand, I'm going to demonstrate how to use the calculator. All right, so first thing that you want to do is go into the stat section of the calculator. All right, so you want to use the stat button, and this menu pops up. All right, the edit menu. When you select edit, it's going to take you into all of the different lists where you can list out the data that you've gathered. Now, unless you tell the calculator what your data is, it's not going to know what to use to calculate. It's not a mind reader. You actually have to enter your data in order for it to do anything with it. All right, now I happen to have all of the data from fall 2021 entered into here, but I'm going to use list 2 to just kind of demonstrate how this would work if this list had been cleared. All right, so I would need to type in 63, then I would hit the enter button, and then 65, hit the enter button again, 63, hit the enter button again, and so on until I have all of my data listed. Now, if I want to clear out a list, I would go up to the very top and use the clear button. Notice the phrasing I use. I want to clear this out. I don't want to delete the list. I want to clear what's in it. So if I hit the clear button, notice that everything has disappeared from down here, but this has not yet cleared out. That's because I haven't actually completed the operation. I have to hit enter, and then it shows that it's fully cleared out in the list itself. All right, now since I already have all of this data entered in, I'm going to go ahead and take us to our next steps to save us a little bit of time. All right, anytime you want to calculate the statistics for any data set, enter your data first into the calculator. Remember, go to Stat, then hit Enter on Edit, and it'll take you to the list. Now, once you have your data entered, you still want to hit Stat, but this time, notice these other 2 menus, Calc and Tests. Now, tests are used in more college-level statistics courses, but Calculate is definitely something that we use. Notice our options here. One var stats, that stands for one variable stats. This calculates all of the statistics that I could need with one variable. And I'm going to hit enter on this. Notice my list is list 1. That is where I entered my data. If you end up with a calculator that says something other than list 1, notice that right above the number keys, you see the list names written in blue. So you would hit the second button and whichever number key you need to get the appropriate list name if you need to replace this. Frequency list is only used when you've already calculated the proportion of times numbers within your data set occur. We did not do this, so we're going to leave the frequency list empty. All right, we're just going to go straight down to calculate and hit enter. Now the numbers in this listing, X bar right here is our mean. All right, sigma x stands for the sum of all of the numbers. Sigma x squared stands for the sum of the squared values in the distribution. S sub x is our standard deviation. Sigma sub x is the population standard deviation. We don't really use this one. Then we have our sample size of 34, our minimum of 59, first quartile of 62, median 65, third quartile 67, our maximum of 72. All right, so let's see. We need to calculate all the summary statistics, and we actually have them all here. So I am going to just kind of list these out down here. All right, so our mean is equal to 65.03 approximately. Our standard deviation is 3.38 inches approximately. Now this means that on average, the heights of my students in 2021 differed from the mean of 65.03 inches by about 3.38 inches. Right, so it's the average difference between the heights compared to the mean. Now, my 5-number summary itself, my minimum is 59. My first quartile, notice that 1 is written as a subscript, is 62. And I need to hit the down arrow. You see this down arrow right next to first quartile? All right. When you push that, it extends to the rest of the list. So I can get my median. There isn't really a symbol for median. All right, each of these should be in inches. My third quartile, 67 inches, and my maximum of 72 inches. Now, something to note, do you see how close my median and my mean are? They're very, very similar. They're almost the same, which confirms the fact that my distribution was, in fact, roughly symmetric. All right, now, I'm going to go ahead and calculate the interquartile range just so that we have it for tomorrow's work. All right, so remember, interquartile range is third quartile minus first, which in this case would be 67 minus 62, which means the middle 50% of the data was spread out about 5 inches in all. Right. Now, during class tomorrow, I'd like for you to calculate the summary statistics for each distribution gathered from your survey questions and check your work with your group members. All right, see if you remembered how to do those calculator steps the same way, correctly. All right, I'll see you in class.